Hi everyone. In wireless communication, packets can fail due to noise, fading, or interference. So, how does 5G ensure that data is still delivered correctly? This is where HARQ or Hybrid Automatic Repeat Request comes into play. In this video, we will understand what HARQ processes are, how downlink HARQ timing works, how uplink HARQ timing works. Let's start with the basics. What is HARQ? HARQ stands for Hybrid Automatic Repeat Request. It is an error control mechanism used in wireless systems to ensure that data is delivered reliably. In 5G NR, HARQ is handled mainly by the MAC layer and the physical layer. The idea is quite simple. When the transmitter sends a transport block, the receiver checks whether it was decoded correctly using a CRC check. If the CRC passes, the receiver sends an ACK, meaning the transmission was successful. If the CRC fails, the receiver sends a NAC requesting a retransmission. But instead of simply retransmitting the same data, HARQ allows the receiver to combine multiple transmissions of the same data. This improves the chance of successful decoding. This is why it's called as hybrid ARQ. It combines forward error correction and retransmission. Now let us talk about HARQ processes. HARQ uses a stop and wait mechanism. This means that for a given HARQ process, the transmitter sends data and then waits for the ACK or NAC before sending the next data or retransmission. However, waiting would reduce system efficiency. So 5G NR solves this problem by using multiple HARQ processes in parallel. While one HARQ process is waiting for feedback, other processes can continue sending data. This keeps the radio link fully utilized. In 5G NR, the maximum number of downlink HARQ processes is around 16 or 32. Each process is identified by a HARQ process ID. Now let us talk about DCI and HARQ processes. The G node B controls HARQ behavior using DCI messages on the PDCCH. Typically, DCI formats 10 and 11 are used for downlink scheduling. These DCI messages contain important HARQ parameters such as HARQ process ID, NDI or new data indicator, and RV redundancy version. Let us briefly understand these. NDI or new data indicator tells the receiver whether the transmission contains new data or if it is a retransmission. If the NDI value toggles compared to the previous transmission for that HARQ process, the receiver treats it as a new data. If it does not toggle, it means that the transmission is a retransmission. The redundancy version or RV indicates which encoded version of the same transport block is transmitted. Different retransmissions use different redundancy version so that the receiver can combine them effectively. Now let us look at downlink HARQ timing. Consider the following sequence. Suppose the G node B sends a DCI message at slot 100. The corresponding PDSH transmission occurs at slot 100 plus K0. The UE sends the HARQ feedback, meaning ACK or NAC, at slot 100 plus K0 plus K1. So the sequence looks like this. So DCI, then PDSH, and then ACK or NAC. If the G node B receives a NAC, it can schedule a retransmission for the same HARQ process. In this retransmission, the NDI remains unchanged and typically a different redundancy version is used. The UE then combines the retransmission with the previous reception. So this technique is called as soft combining and it significantly improves decoding performance. When the G node B wants to send new data on that HARQ process, it simply toggles the NDI, which tells the UE to flush the previous buffer and then start fresh. Another interesting detail is that the UE can send HARQ feedback for multiple PDSH transmissions in the same slot. The HARQ codebook defines how these feedback bits are organized. Now let us talk about Uplink HARQ. For DCI based dynamic grants, the process is similar for uplink scheduling. Suppose the G node B sends a DCI at slot 100. Then the UE transmits the push at slot 100 plus K2. The G node B then checks the CRC result of this push transmission. If the decoding fails, the G node B can schedule a retransmission for the same HARQ process. In addition to dynamic grants, NR also supports configured grant transmissions. In this case, the UE already has a pre-configured uplink resource. The first transmission occurs using this configured resource. If a retransmission is needed, the G node B can schedule it using a DCI addressed to the CSR NTI. So typically with NDI equal to 1. This mechanism reduces control signaling overhead and it is useful for low latency uplink transmissions. To summarize, HARQ is a key mechanism in 5G NR and it ensures reliable data delivery over unreliable wireless channels. It works by combining retransmissions, forward error correction, and parallel HARQ processes. Together, these mechanisms enable high reliability while maintaining high throughput. Understanding HARQ is essential for anyone working with 5G MAC or physical layer implementations. If you found this video useful, consider subscribing. In future videos, we will dive deeper into topics like HARQ codebooks, scheduling, and MAC and file layer procedures in 5G NR. Thank you for watching. Bye.